One of the announcements this week was a potential future telescope that's going to be one of the ground-based telescopes that's going to be looking at these objects. It's called the Extremely Large Telescope, the E-ELT. It's going to be 38 meters across, and the news item that actually just came out today is this is going to be a European Space Observatory project, and that they just announced the contract, the largest contract that they ever issued, that ESO has ever issued, just a mere 400 million euros to build this thing and start getting it started. So it's a place going to be in South America. They've already leveled the site, and they're going to start to build it. It is an amazing technology that has now been developed. We're building our a similar one called the 30-meter telescope on Mauna Kea in Hawaii, but this is their fleet of large telescopes right now. These are the very large telescope. So now that's why this is the extremely large telescope. But these are 4 8-meter telescopes, and they have some other like 4-meter telescopes as well. You can see how large it is relative to it. This is 80 meters, so that is like 90 yards or so. So we're talking, the length of this is the length of a football field. And it has to rotate that dome and control a telescope with unbelievable precision over the course of this mirror. And the mirror is going to be a bunch of tiled segments of individual, like hexagonal shaped mirrors that form one large mirror. So it's going to do some great. The other thing that I just wanted to mention was a nice little story. We are constantly, I mean, the race is on to try to find life in our universe. So we really want to try to see what we can do with some of these other objects that are out there in our solar neighborhood. And so we're developing new techniques to help actually detect some of these other planets. So one of them is to detect them around solar-like ones. Well, the techniques that with the ultra cool ones, the nice thing was the object was a lot bigger. In the case of watching an Earth go around the sun, the dip in brightness is only about one part in 10,000. So how are we going to see these really faint stars and image them and see their atmospheres? So I'm going to show you a little video clip that describes a really cool technology that they're developing for space telescopes, and it's called a coronagraph. In this case, an advanced coronagraph. And it'll be narrated, and I'll comment on it. It's kind of ominous, too.
A distant star is orbited by 2 planets. One looks similar to the Earth, the other is a gas giant. When viewed from a distance, the 2 planets disappear into the glare of their sun. How could we ever find these planets all the way from the Earth? By using a space telescope with a coronagraph to separate starlight from planet light. As the star's light passes through the telescope's large mirrors, it picks up small distortions. Diffraction adds concentric rings to the image we see. To reveal the planets, first a coronagraph uses a mask to block much of the star's light and redirect the remaining light to the outer edges. A washer-shaped device can now block most of the rest of the star's light. Because the planet's light comes in at an angle, it misses the mask and passes through the center of the washer. But when we turn up the image signal by collecting more light, we can see that the planets are still hidden under blobs of leftover starlight. To remove these blobs, the coronagraph has a special deformable mirror that can change shape by using hundreds of tiny pistons. This can correct distortions in the light beam. As the mirror deforms, the blobs of light as seen in the monitor slowly begin disappearing, finally revealing the brighter of the 2 planets. Afterwards, the fainter planet also comes into view. We can now see objects more than 1 billion times fainter than the star. And if the light from these planets is passed through a prism, we can spread it out into rainbows of color. But some colors are missing. They were absorbed by gases in each planet's atmosphere, giving us important clues about their composition. The search for life in the universe has taken a new step forward.
They had a longer version of this video that explains some things there. I wanted to clear up just a few misconceptions. They talk about the glare of the star itself, trying to see it in the glare. It's really not, it's not like there's anything out by the planets that's reflecting light that's causing that glare. So it's not analogous like if you try to block the sun to get rid of its glare, you still have stuff that's coming off the atmosphere. All the glare is due to the fact that the light is diffracted in the telescope, and you saw that thing where they saw a bunch of different rings in there when it made the image, and that's what that whole process of putting the Leo stop and the washer and things in there to get rid of that. And then the other little imperfections that they have a deformable mirror on are actually imperfections in the mirror itself. So it's very cool technology, though, that they're developing, and it will have the potential with our next generation of telescopes to actually detect these kind of planets. And so one of our next generations, which is the top-rated next kind of follow-on to the James Webb Space Telescope, which is the follow-on to the Hubble Space Telescope. James Webb will launch in about 2018. This one here, the Wide Field Infrared Survey Telescope, they're developing these coronagraphs for this particular instrument at the moment. It's not going to be as big as the James Webb. It's going to be about 2.2 meters, but it's going to see large parts of the sky, and it will have some of these other capabilities. This one won't get built into the 2020s, but it is the #1 priority based on the last decadal survey that we did in astronomy. So this is my last slide, but this object is very, very interesting. We don't know that much about it. Like I said, these planets go around every day and a half, 2.5 days. They're so close that their orbits are their planets are probably tidally locked. In other words, just like the moon has one direction that's always pointed toward us as it goes around, there will always be one side of these planets pointing toward the sun. So that has some implications of what type of life could potentially be there, but there is speculation that life could be in the kind of where the terminator is. In other words, where if you were standing there, you would be seeing the sun right on the horizon. So not until we get these larger telescopes, and we have, for these particular objects, we do have telescopes like the 10-meter telescopes on the ground, the 8 meters like the very large telescopes that can actually look at these and find more details about these objects. We'll find out if they are indeed more massive. Are they rocky? Are they gaseous? Are they more like iron planets like our Earth? All right, well, stay tuned on that. And so this was just discovered this month, so I'm sure a lot of big telescopes are looking at these objects right now. All right, thank you, and I'm going to turn it over to Kachin.